Another one of these interesting problems where you're given an initial condition where you're led to believe you may need to solve for x to evaluate another expression, but that's not the case here. It turns out you never have to know the value of x just due to the algebraic structure of this thing. Now, so we're given this initial condition right here, 49 raised to the x plus 49 raised to the minus x is equal to 167. And we're supposed to evaluate 7x plus 7 to the minus x. Now, I tried to simplify this at the beginning, and I realized I couldn't get anywhere that way. And I realized that if you square this, you get something that looks like the given. And so this well-known identity, a plus b quantity squared, helped us out. What I did, you can see, I just squared it and took advantage of the structure of this algebraic identity. And also just properties of exponents. 7 to the x squared is 7 squared, or 7 to the x quantity squared, but then you can multiply the exponents. That's properties of exponents. And notice right here we have 7x times 7 to the minus x. That's really the same thing as just, you can write that as 7 to the x over 7 to the x, right? You can write it that way, you can just use properties of exponents, but that's 7 to the x over, that's 7 to the x over 7 to the x, which is just 1, but then 2 times 1 is the 2 that you see right here. And also right here, 49 is the same as 7 squared. So that's 7 squared quantity, or just 7 squared raised to the x power, okay, is how that's working. Okay, y'all, again, I hope this is legible. This is supposed to read 7 raised to the x power. The minus means take it to the denominator, or you can just do adding the exponents. X plus minus x is 0, 7 to the 0 is 1, however you want to think of it, okay? But you see, this works out very nicely because this 2 just adds to the 167. The initial condition says 49 raised to the x plus 49 to the minus x, which you see here and here. Well, this part and this part is combined to give you 167. That's just the initial condition. Plus 2 is 169, which we recognize as a perfect square. 169 is 13 squared. So we do take the plus and minus square roots, and we get what appears to be 2 solutions. But notice this part right here, this piece right here is always going to be greater than 0, okay? And if you just think about it, the graphs, or remember, something raised to a negative power is still positive. Like, for example, 7 to the minus 2 is still a positive number. It's 1 over 49. So you see this entire part that I've circled is greater than 0. And so we would reject this minus sign right here. So the only answer would be just plus 13. I'll write a parenthesis there, plus 13. Mathematically, as far as taking the square roots, you would get, if you're just dealing with an unrestricted expression like x, for example, you would have plus and minus solutions. But 7x plus 7 to the minus x is always positive. So anyway, that's the answer, y'all. Plus 13 is the solution. Hope you enjoyed.